Let's do one thing. Let's get started. So first of all, happy Ganesh Chaturthi to you all. I know it's a big festival. Ideally, we should be able to skip these classes, but I thought no, skipping is easy and that brings a lot of discontinuity also. So we'll just keep the momentum. It's just a 1 hour class, so yeah, we should not take much time, and most of the celebrations are happening in the evening, so that way, yep. Here's Vaibhav. Hi Vaibhav.
Hi, sir.
Okay. So yeah, I was just wishing everybody happy Ganesh Chaturthi, and let's get going. So first of all that we have learned in Unit 4 so far, is everybody clear about those concepts? Are there something that is missing, that is something that needs to be explained, or you would rely more on what you have learned versus what you would see in the video before asking me? I would think that okay, let's assume for now that whatever we have learned that well enough. But yeah, if there's any question, obviously everybody can reach out to me on WhatsApp and say, sir, this part I'm not clear. And trust me, I would not take it otherwise also. If there's something that you're not clear about, just don't hesitate to ask. Okay? Alright. So what are we going to learn today? Who all has got a chance to see what is there in the class plan for today? So there are two things that I wanted to cover. One was quadratic and exponential word problems, and second one is interpreting non-linear functions. So there are two things that we'll try covering. So quadratic and exponential word problems. First of all, everybody knows what is a quadratic function, quadratic equation, what is exponential function. Can I assume that part is clear to you guys, or?
Yes, sir.
It's clear, right?
Yes, sir.
Okay. So I will just take maybe a minute or a minute and a half to just touch upon those. When we say quadratic equation, we are talking about an equation in the form of this. This is the most standard form of a quadratic equation. Now it can be in the form of, it can be in the form of, let's say, 3x square minus 2x plus 17 equals 0, or this equals 15, whatever it is. But look at this, this is a, because it's a coefficient of x square. This is b, this part is because this is a coefficient of x, and this is the constant part. And again, when you put all the constants on one side, this becomes basically a c. So this is the most simple form of quadratic equation. Now when we say exponential functions or exponential equations, what we mean is something in the form of exponential. Let's say if I say let's say x equals y to the power t, or if I say something like a equals 1.6 to the power t. One of the variable is the exponent, right? Or this is in the form of an exponent. That's why it's called exponential equations. So these things you would know conceptually what exactly it is. What we will do about in the class today is deal with some of the exponential functions or exponential functions or equations, or quadratic functions or equations in the form of a word problem. Okay, which you will end up dealing with in your SAT exam quite a lot. Most of the questions that you will come across in SAT would be in the form of a word problem, meaning there will be a story behind. You'll have to understand or decode that story before you try solving it. So let's look at some examples. And this is the premise of what we're going to learn. So any and every word problem that we'll deal with today would be in the form of a quadratic equation or exponential equations. Let's look at a very classic example of what we deal with. I believe all of you would have solved problems related to compound interest, which says A as in my accumulated net worth, A is a function of P into 1 plus R by 100 to the power T. This is one equation that you would have seen enough. And this, hi Dhanushri.
Hi, sir.
So Dhanushri, we have just started the agenda for today's class. So in today's class, we will talk about word problems with quadratic and exponential equations, and then we'll talk about the second topic is, again I'm quite forgetful, that's why I keep writing it down, interpreting nonlinear functions. So basically we will deal with problems or the concepts which is revolving around these two, and most of them will be in the form of a word problem, which you guys will deal with in your city exam more often than not. So we just started with the basic understanding what is a quadratic equation, what is the exponential equation. I just kind of gave some examples of that, and then we just jumped on to first example of an exponential equation, and this is nothing but the formula for compound interest, if you guys remember, where A is the accumulated value, P is my principal. Let's see if I have $100 and I put that in a bank, and bank says that I will give you 5% interest year on year. Okay, so if I keep my $100 in the bank, which is offering me 5% interest year on year, after let's say n number of years, which is T here, what would be my total amount in the bank? Let's say if I put $100 in the bank is saying that okay, if you keep $100 with me or any number with me, I'm going to give you 5% interest. Okay, so my 100 will become 105 after end of 1 year. For the second year, this becomes my principal amount, 100 plus the interest that I got last year. This becomes my new principal amount, and then the bank gives me 5% interest on the top of this. Okay, so bank gives me this much interest. This becomes my new worth, right? So that is in the form of this equation. Okay, so if you look at it this way, right? So is it okay for me to assume that you all have seen this formula? Everybody?
Yes.
Everybody, right?
Yes, sir.
Yeah. So, and how is this formula derived? Would you guys want me to do that, or it's an overkill? Any which way is fine. I can show that. I mean, I can just give an example. Okay? Let's say P is my principal amount. Okay, bank gives me this much interest, this much percentage of interest. So after first year, it becomes P plus 5% of P. 5% of P. So this was my principal amount, and this is the interest I got after 1 year. So this is equals P into 1 plus 5 by 100. P is common both, right? So this becomes this. This is my R. After first year. Second year, my principal amount itself is this, because I got this much interest that got added to my balance, right? So this became my new number. So next year bank will give me 5% of this. So after second year, what will be my new P? It will be whatever was my principal amount, this 1 plus 5 by 100, and bank says they will give me 5% of this. So this is my number 1 plus 5 by 100, So here what you can see is, now this part is common in both. So I can take 1 plus 5 by 100 as common, and then this becomes 1 plus 5 by 100. So what you see is, in the first year it became P into 1 plus 5 by 100, where 5 is nothing but my rate of interest. I can put this as R also. Second year I got 2 of this. Third year I'll get third of this. So that is why in a general form it says the new number after n number of years, compound interest will make your principal change to 1 plus 5 is nothing but my rate of interest divided by 100. And 1 year had one of this, 2 years I had 2 of this, 3 years I got 3 of this. So 2 years, that is 2 square of this. 1 year power 1. 3 years will have power 3. So n years will have power n, or whatever. If t is the number of years, it is t. Oops. Okay, so what I've done just now is, you all would have seen this formula. I was just trying to derive or confirm why this formula came into existence. Was I able to make some sense, or it just was a waste of time? I mean, what do you guys,
Yes, sir.
you were able to relate?
Yes, sir.
Okay, so this is one of my weakness, okay? This is my sincere weakness that I have got. If I have a formula, I always get tempted to figure out why that formula is there. I mean, it could be a problem with me where any formula I cannot absorb it as it comes to me. I always get tempted to figure out why. And that's why I was showing you guys by doing a breakdown of that, right? So, in a way, it helps, it keeps me away from memorizing things. At the same time, I will not have any doubt in my mind why this formula exists, right? All of you would have seen Pythagoras theorem. I have seen too, but I kind of broke it down, say, okay, fine. Why that came into light? How did it exist? So in my previous class I proved that. Similarly, all the theorems for congruence. Why? Doing that. So it might be a bit of waste of time at times for you guys, thinking. I mean, everyone knows this formula. I have to just apply the formula. Why to even bother about proving it? But then, this is where the concept is. If you put that extra effort to kind of decode the concept or make sure that how the formula came into existence, that strengthens your concept or conceptual view of things. Okay, so that's why, even if I am wasting a little bit of time for you all, trust me, that is not a wastage, that's an investment. Yeah. So now coming back to the actual agenda, right? When I was talking about any value based on this formula is nothing but a classic example of an exponential function, as you can see, where t is the exponent. If you keep your money which in a bank which gives you this much rate of interest for this many years, this will be your new value. Now, here what is fixed? This is fixed. This is also fixed. What is changing is the duration. Or you can also look at this way, that your net worth or your net value in the bank account is a function of these three things. If you keep more money, your net value will be more. If you keep same amount of money but you get a better rate of interest, your net worth will be more. Or if your amount saved and rate of interest remains the same, if you keep it for a higher duration, for more number of years, your net earning or net worth in the account would be more. So these are related, but in the form of an exponential equation. Now let's look at another example. So here, when you look at this kind of equation, you know how to solve it. What I'm saying is, this is a classic example of exponential function, or exponential equation rather. Now let's look at another example where, let's say you get a word problem which says height of a stone thrown upward depends on time following this equation. Let's say height of a stone thrown depends on 3t square plus 5 by 4t minus 30. Let's say you are given this equation saying that height of a stone, let's say if I have thrown the stone here, this is my height. Let's say I'm throwing the stone from here, I'm throwing it upward, and it makes this movement or no, follow this trajectory. Now it will say, okay, fine. After 5 seconds, if this is the equation to be followed, after 5 seconds, find out what will be the height of the stone. Meaning, after, let's say 5 seconds, let's say the stone is here. What you have to do is, you have to just put time here, and then that will give you what will be the height. Let's say there can be a question where which they will just tweak it a little bit, say, okay, fine. This is not the right equation actually. Let's say this is 5. Okay. Now, and this is in feet. Okay. Let's say when the zero time has elapsed, what is the height of the stone? When the zero time has elapsed, from this, by looking at this equation, okay, I mean, again, there is no mathematical calculation or formula that we are going to apply here, right? This is just an equation given the problem, saying height of a stone thrown upward follows this, where t is the time in seconds and h is the height in feet. Okay. Now, what will be the height of the stone from the ground after 2 seconds and before the stone is thrown? Okay, this is the equation that it follows. Before the stone is thrown, what is the height of the stone from the ground? And after 2 seconds, what is the height of the stone from the ground? Can you guys tell me what will be your approach? And again, let me repeat it. Right? A stone thrown upward follows this equation. This is given the equation. Okay. Now, where t is the time elapsed in seconds and h is the height of the stone from the ground after that time. So tell me what is the height of the stone from the ground before it is thrown, and or I might say, okay, tell me what is my height. This I'm throwing this stone. This follows the equation. Tell me what is my height. Can anybody guess my height? I mean, that might not be accurate, but as per this equation, yeah.
You would put t equals 0 because you still haven't thrown it yet, and then you would find out that your height would be 5.
Yeah, because that will be the height of the stone. So, if I'm keeping it here on my head, that is my height. If I'm keeping it here, I'm saying that, okay, I can make it more complex, say, okay, the stone is kept 5 inches below my top of my height. So before the stone is thrown, tell me what is the height. So stone is here, you have to add 6 more inches. So again, I'm not sure if you guys are finding this question interesting or confusing. Let me repeat this. This is the relationship between height and time. So that if the stone is thrown, this equation depicts what will be the height of the stone from the ground after elapsing any time. So by looking at this equation, tell me if I am the person who is throwing the stone and I'm keeping the stone 6 inches from top of my height. Tell me what is my height. Any guesses? I mean, no guesses. It's a mathematical problem, by the way. 5 feet 6 inches. Okay. Pranit here in the classroom is guessing my height to be 5 feet 6 inches. I'll ask him why, but anybody else on the screen? Anybody? Tell me what is my height and then how would you derive that? First of all, is the question clear to you guys? Atharv, Arya,
Is it just 5 feet? Is it 5 feet?
So I added some more spice to the question, okay? So I said, this is the equation which tells what will be the height of the stone from the ground after any number of seconds or times elapsed. I'm saying, and I'm keeping the stone 5 inches below top of my head. Okay? So if I keep the stone here, right? I cannot throw it, right? I mean, or maybe I can throw it like this from here. But I'm saying I'm keeping it here and then I'm trying to throw it. So if I'm keeping the stone 5 inches below top of my head, below my maximum height or maybe, then tell me what is my height. So yeah, Atharv, you said 5 feet, but I want to hear what is your thought process behind this. I mean, how are you looking at it?
Wait, T is the times elapsed, right? In seconds.
T is the time elapsed in seconds. Yes.
Okay, so I just plugged in 0 because that's where it starts.
Yes. And that is, yeah. Continue.
And that only left the 5.
Right. So basically, see, I can keep the stone here before throwing it, or I can keep the stone here right on my head so that I can get the exact measurement of my height, right? So I'm saying that the stone is kept 6 inches below my tip of my head. So basically that means the height of the stone from the ground is here, which is 6 inches less than my height. So whatever comes the height of the stone from the ground, I will just add 6 inches to that. That will give me my height. Does it make sense? Yeah. Now, the second part of the question was, what will be the height of the stone after 2 seconds? So like Atharv has put 0 here, or Pradip mentioned that he will put 0 to know the starting point of from where I am throwing the stone. What will be the height of the stone from the ground after 2 seconds? What will you do? You just put a 2 in place of t. And then you will get 3 into 2 square, 5 by 4 into 2 plus 5. Yeah? And that will be your height. Of the height of the stone from the ground. So, net, what I am trying to say is, for all the quadratic equations that we have dealt with, all the exponential functions or equations that we have dealt with, it is not going to be anything different from that. Only thing is, you have to read that question again and again and use this most stupid formula that I keep talking about always. Okay? I hope everybody knows what is tran by now. Vaibhav would know, Tanushree has heard it enough, she is tired. Atharv would know for sure. Shivatsa would know it as well. Pranit anyways knows. Ananya and Arya, do you guys remember what is, and Shravya, would you remember what is tran?
I think so.
You do, okay. No, see again, my intention is not to get you guys bored, okay? My intention is to emphasize the fact that reading the question again and again is very important part of solving a problem. The biggest mistake that we commit as a examinee when we are in front of a question paper and trying to solve it, we are always in a hurry to solve it. I'm saying no, don't do that. Step back, read the question a couple of times. Because if you read the question, your problem becomes much more easier. Let me do one thing. Let me give you guys a real classic example or a question directly from Khan Academy, and we'll try solving it together. Okay? Applying this stupid formula strand. Okay? So let me pick up one quick question from let me go to a simple question paper. Okay. I'm just reading the question for you guys, okay? Poultry should be cooked to a temperature of 75 degrees. It says poultry should be cooked to a temperature of 75 degrees. A chicken is removed from the oven. Is everybody vegetarian here? Anybody who is a strict vegetarian cannot stand by the name of the chicken also? Okay.
Me.
Okay, you're okay hearing chicken, right? You don't have to eat chicken, for sure. This is just a question, okay? Let's take this question as a question, okay? Let's not worry about the eating part of it. So don't worry, okay? I know Dhanushri also might not have eaten chicken, right? Or you do? Okay, let me not go there. That is not needed. That information is not important. So let's look at this question as a question, okay? So it says poultry should be cooked to a temperature of 75 degrees. A chicken is removed from the oven and left to rest in a room temperature that is at a constant temperature of 22 degrees. So this is the temperature at which it should be cooked. It is taken removed from the oven and left to rest in a room temperature that is 22 degrees. This is the room temperature. The temperature of the chicken T hours after it is removed from the oven is given by the exponential function. It says temperature of the chicken after T hours, this is in hours, is given as this. 22 plus 53 multiplied by 0.74.
Wait, is it lagging for y'all?
Yeah. Yeah, he's not lying.
Yeah, it's like bad. It's like pixel.
Really bad? Okay. Okay. Can you guys hear me okay now? Slightly better?
It's lagging really bad.
Really
I
bad?
can't even hear you.
You can't hear me? Okay. Anything better now? Is it any better now?
Sir, I might think you need to leave and rejoin. I think you might need to leave and rejoin.
Okay.
Oh, yeah, you're glitching. I thought my internet was glitching. That's why I can't.
Yeah, I thought.
Yeah, I tried leaving
Number
and
was
joining
bad.
again and it didn't work.
Okay, let me do one thing. Let me reconnect. Okay? Drop off and join back again. Let's see if that helps. I will come back again, okay? I will join again.
Okay, sir.
Okay. Okay. Can you guys hear me okay?
Yes.
Is it better now?
Yes. Yeah.
Okay, good. So what we just started was, I just picked up a question from the Khan Academy unit test, okay? And we are just trying to solve it. There's nothing new that we have learned, it's just a simple word problem. And we are trying to solve it by following my my very own boring formula, okay? So I'm just reading the question for you guys, okay? It says, poultry should be cooked to a temperature of 75 degrees centigrade. So, be it poultry or be it anything else that is edible which is getting cooked, it is to be cooked at 75 degrees. A chicken is removed from the oven and left to rest in a room temperature, in a room that is a constant temperature of 22 degrees. So this was getting cooked at 75 degrees. It was taken out and put in the room which is at a constant temperature of 22 degrees centigrade. Now it says the temperature of the chicken T hours after it is removed from the oven is given by the exponential function this. So this one says that after T hours, the temperature of the chicken or whatever was getting cooked at 75 degrees will be this. So let's say after 1 hour, I will put T as 1 and find out what will be my temperature of the chicken. After 2 hours, I will put T equals 2 and I will get the temperature, what will be the temperature of chicken. So this equation says that what will be the temperature of the thing that is taken out of the oven after and kept in the room with this room temperature. This will be the temperature after n number of hours, and this is that. Okay. It says what is the approximate temperature of the chicken after 2 hours. It says what is the approximate temperature of the chicken after 2 hours. Okay, after 2 hours, and the answers given are 22 degrees. This is A. B is 51 degrees. C is 74 degrees, and D is 75 degrees. So again, now T is something that doesn't exist in my life. Okay, if I would have ever had any trust issues with my own knowledge, skill or ability to solve problems, I would have not studied, I would have not dared to teach any of you for sure. So T doesn't exist, and I would want you all to have that T out of your equation. Say, okay, fine, I know math, if anybody can solve, I can solve. That would be your approach and beliefs. So we'll start with R. R is read the question again, and that's what I'm doing right now. We don't have to rush for solving it, okay? I'm just trying to give you guys an approach. This question said that the poultry is cooked at 75 degrees centigrade. Once you take the chicken out of the oven and keep it in the room, which is at temperature this equation tells you what will be the temperature of the thing that is taken out of the oven after any number of hours. And T is in hours, and this is whatever, this T is in hours, and this says this will be the temperature. After a certain number of hours, this will be your temperature. That's what the equation says. And what it is asking is, tell me what will be the approximate temperature of the chicken after taking out of the oven after 2 hours. Approximate. You don't have to struggle to find out decimal and all those fancy stuff. You have to give the approximate value. Now, this is where I will stop. I want to hear from you guys, what would be your approach? Again, I'm repeating myself. It says, this is the temperature at which it is cooked, this is the room temperature, and this equation tells you what will be your temperature after certain hours have elapsed. And the question is, tell me the approximate temperature. So if my calculus is 23.2, I would not want to worry about 23.2, I will just say 23. So I want to hear from you guys, what would be your approach?
I would round 0.74 to 0.7, making it a little bit more easier.
Mm-hmm.
And then square it, which would get you like 4.9, and
Mm-hmm.
add to like 5. So then it would be 5 times 53, then you add it. Wait.
Okay. on the screen. I got one response. I'm just trying to understand your approach. See, this is asking you for this is the equation given. You have spent a lot of time just because I misguided you guys, telling that you have to read the question again and again. That means you'll probably spend more time than what you used to spend before for reading the question. Now you have to find out a way where you are going to save time. So that is where some trick will come into picture. So I want to hear from you guys. I'll come to you. Let me hear something from the screen. I'll come back to you. Okay. So again, in today's class, I'm not trying to learn a lot of things. I'm just trying to emphasize more on the conceptual part or the approach part. Okay, because that's what the word problems are all about. So yeah, anybody on the screen, what would be your approach? How would you think about this problem? Yes, Atharv.
I would first check my word problem and like I would check is the equation right with the word problem.
Mm-hmm.
Then I would check what the variable is in the equation.
Mm-hmm.
Then I would check the word problem. Is there a value for the variable?
Okay.
Then I would plug the variable in to like solve it.
Okay. So now just to make sure that we are using some elimination technique. Here we have this equation already. We know that after this is my room temperature, this is the oven temperature. After 1 hour, if I put 1 here, it will give me some value. After 2 hours, it will give me some value. So probably finding the value of the variable, that part you can skip, because you now it has come down to a point where you have to find out how it is increasing or decreasing, and you have to get an approximate value, right? So what is the hourly decrease or increase in temperature that is coming into play, right? So I would lean more on looking at this part after having read it enough to be able to derive some conclusive view. Okay, so yeah, Atharv, so whatever you said, that was perfectly fine. There was nothing wrong with that, but I'm just trying to get a little more clue here, which is more on the calculation part. So Atharv, you can think about it. I'll come back to you. Pranit, you were saying something.
C and D are not likely possible for maybe the D, I wouldn't say, because even after 1 hour, the temperature would have decreased because of the decimal in there.
Mm-hmm.
So D is not possible.
Mm-hmm.
So we could cancel D out and focus on the other 3.
Okay. Okay, so there's one good point I got here. See, there are 2 ways of solving a problem. Once you have a question, right, you can solve it from beginning to end and then get the answer. Second approach would be that if I solve it, I'll take some time. Do I have a way to eliminate something without even solving the problem? See, I mean, I would be termed as a bad teacher who's kind of asking you guys not to solve the problem, right? But then ultimately, as a student, what is your objective? You're trying to get it right in the least possible time. What Pranit is telling me is, I will simply not look at option D at all, because this is the temperature at which something is getting cooked, 75. If I take it out and keep it in the room temperature, which is below this, 75 is higher temperature, this is lower temperature, meaning it will start coming down. So it will not be 75 for sure. This option I will rule out straight. The question is, what will be the temperature after 2 hours? If you take the chicken out of the oven, which was 75 degrees, keep it out at room temperature, which is 22 degrees, and even after 2 hours it remains 75 degrees, that's a problem. So this is straight away a case of ruling it out. Yeah? Is it making sense?
Yes, sir.
Okay.
Yes, sir.
Now, so one option is gone. So now you have to choose 1 out of 3. If you make a guess, there is a 33% chance that you will be right. Earlier it was 25%, but since you have made a smart guess that it would have not come down, now you have improved your chances of being right. Now, what will be your approach? What is the next approach? What is the next thought process? Okay, again, this problem might get solved without even solving it. Never know. And again, there is no answer which is a wrong answer. Okay, I mean, I'll give you guys 2 more minutes before I try solving it. Are you guys shy, or just because Ganesh Chaturthi today you're not in the mood to make an attempt? What is the deal? Okay, you have one more idea? Yeah, tell me.
You could also let C because 40s after even 1 hour, if it's still like just dropped 1 degrees, it's like 0.75 of 53 is a small number. Added to 22, it's still not going to be as big as like 74.
Right. So yeah, that's a good thought process here. Okay. Now let's go to. I'll just keep these numbers here: 22, 51, 74, and 75. Let's not eat up the whole space here. It says 22, 51, 74, 75. The other 4 options I have, or we all have. This one we have ruled out. Is anybody trying to solve it, or it's okay for me to continue? Okay, let me continue. Now, what is that how I will look at this? This C, it's all a function of this value and this power. That is what is my decider for how much the temperature would be. Obviously, these numbers are fixed, but again, this is where maximum effort is, right? This is a decimal number, all that, tricky part. Now, what will I do? See, 74 or 75. If I get 74% or 75% in my exam, doesn't make bigger difference, right? So I will assume this to be 75, because if I put it 75, this converts into 3/4. Now, what will I do is, after 1 year, 1 hour, if I assume this to be 3/4 or 70.75, then my value is what? This. Now I will do further rounding. Okay, I increase this part, I'll decrease this guy a little bit, so that my calculation becomes easier. Now this is 13. 13 4 is 52. 13 3 is 39. So 22 plus 39. Roughly this is 61. After 1 hour itself, my temperature has come down to 61, approximately 61, maybe 62, maybe 61.5, but somewhere in this range. After 1 hour itself, it has come down to this number. Okay? This is also gone. Because my question is after 2 hours what will be my temperature. Now, look at this. Now let's look at this. This becomes, when this is 1 hour, this is 3/4. If it is 2 hours, it will be 3/4 into 3/4. Yeah. So this will become, this was 39 multiplied by 3/4. I will assume this to be 40. Because we are doing anyways rounding, right? 10 3 is 30. So 22 plus 30. 22 plus 30 is 52. After 2 hours, see, I could have tried being lazy and I would have knocked out this option in the first go itself. Because since this value is not big enough, this number is big enough actually. It's this is not decreasing at a very fast pace. In 1 hour it came from 75 to 61. In the second hour, again it will go by 3 by 4 formula, factor, right? So that will not become 22 for sure. We don't see it mathematically happening, but we just did the calculation here, and we are getting okay 52, which is very close to this one. So this one is gone just by looking at it. This one was gone by rounding it to 3 by 4, and then it was looking very evident that this would be my answer. But just for the safety sake, we use the same 3 by 4. This as 3 by 4. We use one more time for second hour, and we got this one. So here in this calculation, there was no fancy stuff done. We were just doing simple calculation, and we used some estimation techniques, approximation techniques. Say okay, fine. Since it's asking me what will be my approximate temperature, so it's okay to take some approximate value. 0.74 can become 0.75 also, because that gives me 3 by 4. If I would have chosen 0.7, that would have given me 7 by 10. My life was not getting easier. By giving 3 by 4, it became little easy. Since I increased this one, I said okay, fine, 3 by 4. Now I have 4. Can I get closer value which is a multiple of 4? So 53 I changed to 52. So I'm stopping here to see the reaction on the screen. Are you guys able to follow me or go at the same pace, or?
Yes, sir.
Yeah?
Yes, sir.
Yeah?
I can understand.
Yeah? Okay.
Yes, sir.
Okay. So see, here the trick is this. Whenever you have a word problem, obviously good thing is you have all multiple choice questions only, mostly, right? 90% of them. So one thing that will be very, very important, or that will play a very important role for you to get your questions right, would be, I'll say two things. One is solving the problem, and second is eliminating the wrong answers. You don't really want to waste your time and energy for the answers which doesn't hold any value with respect to that question. So sooner you knock it off, it gets a little easier. See, if you look at the whole approach, first thing was, we could see from this itself that okay, if I'm taking it out from the oven which was 75 degrees and keeping it in a room which is at 22 degrees, it cannot be 75, it cannot remain 75 degrees for after 2 hours. That is common sense, that doesn't need any mathematical skill at all. So I can just knock it off. Now I have to deal with only 3 of the answers. Just by, instead of trying to calculate, putting 74 by 100, 74 by 100 2 times, then trying to do multiplication, that would have taken you probably 3-4 minutes. Here you say, okay, fine. No, I don't want to do that kind of a calculation because it's asking for approximate value. So, okay, let me round it off. 74 becomes 75. So 0.74 becomes 0.75, which is 3 by 4. Easier number to deal with. Since I'm doing rounding here, let me do some approximation here also. To get a sense of what is the rate at which it is decreasing. So you're just getting a trend. Okay. So from 75, within 1 hour, it came down to almost like 61. So it is dipping by almost like 14 degrees. See again, you can look at that calculation here again. In 1 hour, it came down from 75 to 61 by 14 degrees. Next 1 hour, do you think it will decrease by from 61 to 22? No ways. You could have stopped it there itself. Then okay, fine. Just by doing t equal to 1, I can see, okay, in 1 hour it came down from 75 to 61. 14 degrees it came down by. So, and my rate remains the same. Next time it will be 3 by 4 of this. 3/4 of 53 or 3/4 of 52. So it is coming down by 13 to 14 degrees per hour. This is what becomes your answer, obvious answer, because if it is coming down by, see, or this is another thing, okay, I could have kept it even simpler. So first thing 75 is knocked off by common sense. Now you are saying, okay, fine, what is the rate at which it is decreasing every hour? So it was 53, 3/4 of 53, it was 39. Now Next time when I go, it will be 3/4 of this number, right? So 3/4 of 39, approximately 10. Sorry, 30. So first time it was 22 plus 39. Second time it became 22 plus 30. You get your answer here straight away. So instead of doing the actual calculation with much bigger decimals, we are actually able to solve it by just doing the approximate value and applying more of a what do you call, more of a what will be the right term? More of a common sense with simpler calculation by putting some approximate value around things. This is one of the problems that we spent 20 minutes, but then what did we learn from this are twofold. One is, yes, we need to know all the equations to be able to solve problems, and that we have learned and that will continue learning. But then what is even more important is we have to learn how to eliminate the things that we don't want to waste our energy for, right? Let's say once you guys, I would not say grow old like me, but once let's go to a job. Once you go for a job, you have a 9 to 5 job, and you're dealing with emails. You will get 100 emails every day, and probably 80 emails would be important, 20 emails might not be. What is that you're trying to do is finding out those 20 emails which you don't want to spend your time for, and kind of eliminate those so that so come on, just give me 2 minutes. So find out where you want to save your time and eliminate the things that you don't need to deal with. So this is where I would want to kind of conclude. We have 6 more minutes. Let me do one thing. I'll give you guys one more sum. Let's look at one more sum, and then I would just want you guys to tell me the approach part of it. Okay. Now, this is the second question, again part of the unit test that you will do. This equation says, just Ankita ji, give me 2 minutes.
Yeah, sure, finish.
Px equals x minus 0.95 multiplied by 500 minus 100x. Okay? It says the equation models P, the daily profit. This is the daily profit in dollars a food truck makes by selling the signature tacos at a price of X. So if this is the price of X, they are making daily profit in dollars. X, okay, what is the daily profit of the tacos? If the tacos sold at, okay, so this says that this equation says that how much daily profit a food truck will make by selling the tacos every day for this price, X dollars per taco. They're saying, okay, how much money they will make if they sell the tacos for $3. This is just a word problem. I would want you guys to think about it. Give me 2 minutes and come back to me telling what the approach would be. Again, I'm repeating the question for you guys. This equation defines what will be the daily profit made by the taco truck if they sell the taco at this price, X dollars per taco. And so this equation says that if they sell the taco for $3 per piece, how much money how much profit the truck will make per day. Think about it. I'll come back to you guys in 2 minutes. Yes, ma'am.
We help him, but we don't know if it's right or not because he is not into it yet.
Yeah.
He didn't know anything, and so I just.
I'm overloading him with
No,
new content. That's okay.
And one more thing, did Bhavika contact you, sir?
Yes, she did. Her daughter is not well today. She's down with fever.
But
Isha,
she-
find a chair, sit down. Yes.
Sure, let's see. Okay, go ahead.
Yes, of course. That's very good.
So she already told her because she was looking for
Yeah, yeah. She contacted me yesterday and today also. She said that her daughter is not well. She's on the fever. And she was saying that even if she takes one class and she doesn't like it, I'll take it and I'll get to know about money. But let her
That's why I
come to
said
the
that
class.
first have 2 or 3 classes and
Yeah.
then you can.
Yeah, I mean, I'm not teaching for later.
Yes, yes, I already told you.
So let the kids enjoy the math and then we'll see.
Yes.
Yeah?
Okay.
Thank you. Thank you so much.
Whose bottle is that?
We'll discuss about that after we finish this class. Okay. Yeah, Praneeth.
Wait, do you want us to approximate or?
Any value.
So I would change 0.95 to 1.
Okay.
Make it a lot easier than plug it in.
Yeah.
We get an approximate answer.
You get the approximate answer. Yeah. Because it's a multiple choice question, right? So you can always say, okay, fine, I'll make this to 1, do that as approximation, and then I'll get the nearest value that I can choose from the multiple choice questions. Okay, that was one of the answers. Anybody on the screen, if you guys have a different approach. Too much of silence is not good. So I'm just trying to understand. See, this was a question that we were trying to solve from Khan Academy, which you guys will anyways do. I'm just trying to understand if this is the question that you are dealing with. What would be your approach? I got one approach here where Praneeth said, okay, 0.95 is very close to 1. If I make it 1, then my calculation becomes much easier because the ask is if the price of the taco is 3. If I put 3 here, 3 minus 1, that's a much easier calculation. And here it becomes 3 into 100, 300, 500 minus 300, 200, 200 multiplied by 3 minus 1. That's a much easier problem. Hello, Savyansi. So Savyansi, you are with a lot of elder kids. Allow me 2 more minutes. We'll finish off the class, then we'll start your class, okay? Yeah, Diti. So just give me 2 more minutes, okay? I'm just finishing on the previous class. Just give me 2 minutes. Okay? So yeah, everybody in the class, what would be your approach for solving this problem? I mean, I'm just curious because you guys are not talking. I'm just a little worried. Ananya, Arya, Savya, Vaibhav. Okay, so it's okay, fine. Let me not put you guys on the spot. So here's the thing. So whenever we have a word problem is a word problem, meaning it just needs us to go through the question enough so that you get the entire content out of it, to understand what is to be solved, how it is to be solved, and then you can apply it for solving it. So I'll probably park it here, let you guys do the unit test with respect to all that we have learned today, and if you get stuck anywhere, that is where it will be an opportunity for us to kind of do a double click on that. Yeah. So in summary, we learned how do we go about solving word problems for exponential equations and quadratic equations. Assuming we know how to solve quadratic equations and exponential equations, and again, when you talk about the word problems, these are more of substitution-ish problems where you have to substitute the value and get the answers. So these are the tricky, I would not say these are the tricky questions. These are easier questions. The only thing is, you just need to do it with a more careful approach. All right, I'll let you guys go and enjoy your rest of your evening. Have a happy Ganesh Chaturthi, and then we'll see you guys tomorrow, same time. Yeah.